A conjecture is an unproven statement or rule that is based on inductive reasoning. So inductive reasoning is when you utilize patterns to make a prediction of what's going to come next. The conjecture is the rule that you come up with. It's the expression or the equation or the algorithm that you come up with to make the prediction of what's going to come next. So as an example, scientists and mathematicians can tell you exactly what time the sun is going to rise tomorrow morning. And again, that would be unproven because we don't actually know that the sun's going to rise tomorrow morning or when. We are simply utilizing the past, the patterns of the past, to predict what time the sun is going to rise. And so they have mathematical models, an algorithm, right, where they can tell you exactly what time or predict exactly what time the sun is going to rise. So that model or that equation or algorithm that they use, that is the conjecture. It's the rule that explains what time the sun is going to rise based off of inductive reasoning. So here, our example, we have dots. So they give us a term, basically a number, n, and then they give us the number of dots for each term. And so if we want to find the conjecture, we need to find the rule that explains how many dots there are for each term. So to do this, one thing we notice is that the dots, there's rows and columns. So we know that the first term is going to have one row and two columns. The second term has two rows and three columns. The third term has three rows and four columns. And the fourth row has four rows, or the fourth term has four rows and five columns. So we notice that the number of rows is equal to the term, right? So the term is just n. So we have n rows. The 100th term will have 100 rows. And then we have 2, 3, 4, 5. So basically we have n plus 1 as our number of columns. So the 100th term will have 101 columns. So we utilize that pattern to come up with these expressions for our columns and rows. And then if we want the total number of dots, we need to multiply, right? 1 times 2 is giving us 2, 2 times 3 is 6, 3 times 4 is 12, and 4 times 5 is 20. So for the nth term, or any number of terms, you multiply the number of rows, n, times the number of columns, n plus 1. So n times n plus 1. You can either even write that out, multiply that out if you want. So n times n is n squared, and then n times 1 is going to be n if we distribute. So that is our conjecture for this problem. That is our rule. That rule will tell us how many dots there are for any term n.